Good morning and welcome to 2021, a fresh new year packed full of opportunity and hope. I wanted to use this opportunity to wish you all a most amazing year, abundant in joy and success in whatever form that most means to you. And I wanted to offer some transparency in sharing with you the value of both our SANS 10400XA energy efficiency standard and dynamic simulation energy modeling, and explaining how these both help ensure better architecture for your clients. I am passionate about great architecture. I am passionate about the integrity of our profession, and I am passionate about ensuring we can competently give our clients good architecture. We all have a legal as well as a moral obligation to give our clients energy efficient buildings that protect our environment and are also cost effective to both build and operate. And dynamic simulation energy modeling done in compliance with the framework of SANS 10400XA is one way that we can certainly competently ensure that. Energy efficiency is important in building design. As we all well know, global greenhouse gas emissions have been rising unabated for decades, which is putting our planet at risk of destructive and irreversible climate change. The Constitution of South Africa places an obligation on us to protect our environment, whilst for us in architecture, Part XA of the National Building Regulations strives to identify a framework whereby we can honour that through competent building design. SANS 10400XA then further defines a set of methodologies for how we might demonstrate compliance against that ambition in the best way we respectfully perhaps know how at the moment. The prescriptive deemed to satisfy framework simplifies how we might satisfy the intent of those goals based on our analysis of hypothetical notional buildings. But in truth, buildings vary immensely in their complexity and performance depending on their unique geometry, orientation, altitude, extent and distribution of glazing, and the effectiveness of shading, etc., even within the same assumed climatic energy zones. The standard also, however, of course, makes provision for us to use energy modeling to more deeply analyze building science performance so that we can rationalize compliance against the intent of that legislation in a more deeply scientific, accurate and cost-effective manner. A report published recently in December indicates that due to the global pandemic and subsequent lockdowns around the world, that global greenhouse gas emissions declined by around 7% last year, which is tremendous news indeed, although lockdowns are certainly not the solution for saving the planet. But it shows us that we can indeed influence our future and the impact we might have on climate change if we all collectively try to. 7% might sound positive, and indeed we'll bank whatever good news we can at this time, but all it really means is that we reduced our carbon emissions collectively from 40 billion tonnes down to 37 billion tonnes. Still way more than all the world's forests and oceans can certainly absorb. It was a forced step in the right direction, a silver lining perhaps in a very dark cloud, but we've certainly all collectively got a lot of work to do. Behind the COVID-induced global slowing greenhouse gas emissions trend, there are 37 developed countries that had carbon dioxide fossil emissions declining in recent decades whilst their economies still continue to grow. They include many European countries such as Denmark, the United Kingdom, Spain, as well as the USA, Mexico and Japan, amongst some others. For the rest of much of the world, emissions have continued to grow. South Africa, which remains the worst polluter on the African continent by a long shot, alone contributing about a third of the continent's steadily rising air pollution, is currently the 14th greatest producer of carbon emissions in the world, with a per capita emission rate worse than China. In Mpumalanga province, has recently been described as one of the world's most air-polluted regions based on satellite imagery analysed by Greenpeace, which is not great news at all. That said, our carbon emissions have positively been on the decline in the last decade, driven in part, no doubt, by the introduction of various legislation aimed at ensuring our contribution to the global challenge and in honour of our constitutional goals. But sadly, also in part, perhaps in truth, because of how our economy has also been on a mudslide in the last decade. Our economy certainly needs desperate stimulation for growth, but we also cannot take our eye off the goal of the larger problem facing the long-term prospect of a poisoned earth inherited from us by our children. Dynamic simulation modelling offers the opportunity to shape building design through an unbiased, deep analysis to ensure that we can give clients buildings that are gentle on the environment, cost-effective to build, cost-effective to operate, and ensure thermal comfort to inhabit. Using state-of-the-art, internationally recognized 3D energy engineering software in hand with realistic meteorological data that is both location and altitude specific to any building anywhere, we can simulate and intensely interrogate building science performance to inform the design process about exactly what concepts, building methodologies, and products might work best anywhere and why. A building in the KwaZulu-Natal coastal belt, for example, might perform quite differently to a building just 30 kilometers or so inland in Hillcrest, which is at almost 900 meters altitude. So the optimized construction technology solutions of one are not necessarily the same as the other, and thus often benefit from competent performance analysis. Through dynamic simulation modelling, we can better optimize exemplary architectural design to help ensure that your clients get the best architecture they can in direct alignment with the dictates of all the legislation and for the specific budget they have available. Our simulation modelling is immensely intense. We develop a 3D model of whatever your project is. Then we run sunpath checking algorithms over that model using real-time localized meteorological weather data that is programmed to stop every 10 minutes, 365 days a year through those simulation runs to analyze and report on all the direct and indirect heat gains and losses on every single element of that building. The data that we get to analyze is immense. The simulation studies also include items like the heat emitted off of light bulbs internally, metabolic heat emitted from occupants, air leakage, solar gains conducting through the thermal mass of the building envelope, heat radiating off internal surfaces, the energy used through various forms of hot water heating, as well as the effectiveness of shading from the building's own specific geometry, roof overhangs, screens, window reveals, etc. We can further run a glazing analysis on an endless plethora of various glass specifications to help optimize what glazing specification might bring the best performance to any building anywhere in terms of minimized energy consumption, maximized thermal comfort, and return on investment, comparing capital cost expenditure against simulated return on performance. We can adjust the specification of any individual element of the building envelope or internal services to analyze and review any benefits thereof in refining design specifications. We can also specifically simulate either natural ventilation studies or various forms of air conditioning and mechanical ventilation to suit the aspiration of any building design and use. I don't necessarily consider myself to be an environmentalist, but the earth is in a mess, and we are certainly all collectively responsible for it. Anywhere in the world, national building regulations and the national standards that serve them define the legal parameters against which our designs are required to comply. But it is the level of our own individualized moral and ethical integrity that define how deeply we are each prepared to dig to make the difference that is required of all of us. I know that money always talks. that projects are always defined and confined by client budgets. I'm a money man. I studied economics. I've worked in mega project design development, but I'm also a design man. I'm professionally multi-qualified in architecture. And so I'm indeed confident that there is a way to balance it all, to give our clients really good architecture, fully compliant with all the dictates of legislation, that is aesthetically exquisite, but also embodies the functional performance that is required to ensure those buildings touch the earth gently and minimize our impact on the planet. Competent dynamic simulation modeling is a phenomenal tool to empower us to achieve a better understanding of exactly what solutions work best, where and why. Please feel free to give me a call or ping me an email if this aligns with any of your own aspirations for how you envisage that the architectural profession can indeed be the shining light that illuminates our path forwards. I wish you all a most rewarding 2021, doing what you love most, designing and developing exquisite architecture with passion and integrity, and serving your clients to the very best of your ability. Thank you.